Secondary batteries. What are secondary batteries? Secondary cells, they can be recharged. They can be recharged by passing the current in the opposite direction. So it can be used again and again. After use, it becomes discharged, and if current is passed through these batteries in the opposite direction, then it can be recharged and can be used again. Good secondary battery can undergo a large number of discharging and charging cycles. Most important secondary cell is the lead storage battery, which is commonly used in automobiles and inverters. The lead storage battery consists of anode, that is the negative plates, made up of lead. In the diagram, it is given as lead grids filled with spongy lead, and the positive plates or cathode is made up of lead grid filled with lead dioxide. The electrolyte solution is 38% sulfuric acid. The reaction which takes place when the battery is in use, the reaction at anode is lead combining with sulfate ions forming lead sulfate, and 2 electrons are given. Here lead is getting oxidized from lead in 0 oxidation state to lead in +2 oxidation state. So it is losing 2 electrons. So oxidation is taking place at the anode. Lead is getting oxidized from 0 oxidation state to +2 oxidation state. At the cathode, reduction takes place. The reaction at the cathode is lead dioxide plus sulfate ion plus 4H plus ions plus 2 electron forming lead sulfate and water. So this reaction is a reduction reaction because in lead dioxide the oxidation state of lead is +4 and in lead sulfate it is +2. So lead changes from +4 oxidation state to +2 oxidation state. Therefore this reaction is a reduction reaction. Now adding the oxidation and reduction reaction, the overall reaction will be, the overall cell reaction or the redox reaction will be lead plus lead dioxide. Now 2 moles of sulfate ions plus 4 moles of H plus ion will form 2 moles of H2SO4. And on the product side, 2 moles of lead sulfate and 2 moles of water. Electrons are present on the opposite sides, that is, at anode the electrons are on the product side and at cathode electrons are on the reactant side. So when these cathode and anode reactions are added, the number of electrons get cancelled. On charging the battery, the reaction is reversed, means the lead sulfate which is present changes to lead at anode and it is converted to lead dioxide at the cathode. So while recharging the battery, this reaction is reversed. This reaction takes place in the reverse direction and lead sulfate changes to lead at anode and to lead dioxide at cathode. Another important secondary cell is nickel cadmium cell, which has longer life than lead storage cell, but still it is not used. Why? Because it is more expensive to manufacture. The overall cell reaction for nickel cadmium cell is cadmium plus nickel hydroxide forming cadmium oxide, again nickel hydroxide and water. Here cadmium is in 0 oxidation state and it is oxidized to +2 oxidation state. In nickel hydroxide, nickel is in +3 oxidation state and it is reduced to +2 oxidation state. This is the diagram of the nickel cadmium cell. Nickel cadmium cell in a jelly roll arrangement and separated by a layer soaked in moist sodium or potassium hydroxide.